Okay, guys, this is section 2 of Unit 15. We are graphing two variable inequalities in standard form, okay? So remember, this is kind of our refresher here. We want to graph the boundary line. We want to test a point that is not on the boundary line. If that point makes the inequality true, we'll shade that half plane. If it does not, we'll shade the other half plane. Okay, remember, this is kind of the process we went through for the first section. So remember, if it's greater than or less than, strictly less than or strictly greater than, it's a dashed boundary line, okay? If it is less than or equal to or greater than or equal to, it will be a solid boundary line, okay? Something I like to try and think of to help me remember if it's solid or not is this is a solid line that's under less than or equal to or greater than or equal to. Let that be a reminder saying, okay, this is a solid line. It's going to be a solid boundary line, okay? So these are in standard form. If you guys remember standard form, X and Y are going to be on the same side of our equations when we were dealing with them. So the same thing is going to happen when we're dealing with inequalities. So we have negative 3x plus 5y is less than 15. The first thing we want to do is try and get this into slope-intercept form, okay? We do that by adding 3x to both sides. We get 5y is less than 3x plus 15. Now, the reason this right side plays out this way, 3x plus 15, is because you can't combine these. These aren't like terms, okay? I'm seeing a lot of problems with this in class sometimes. You can't combine 3x and 15. 15 does not have an x, so you can't combine them, okay? So you get 5y is less than 3x plus 15. The last thing I have to do to get y by itself here is divide by 5, okay? When I divide by 5, divide everything on the right side by 5 as well, I get y is less than 3/5 x plus 3. 15 divided by 5 is 3. 3 divided by 5 is just 3/5. Okay, there's no point in trying to get that into a decimal when this right here is giving us our slope right here, rise over run. Okay, so identifying our key points now, we're in slope-intercept form. We have our y-intercept. Our y-intercept is 0, 3, and our slope is 3/5. Okay, so let's graph those. 0, 3 is right here. 0, 1, 2, 3. Right there. Okay, now our slope is 3/5. We can go up 3, 1, 2, 3, over 5, 1, 2, 3, 4, 5. Okay, another little key thing that you guys, maybe some of you already know. This is a positive slope right here, right? Okay, where it looks like the skier is going uphill. Okay, that's a positive slope. Now, another thing you can do, if we remember correctly from our math rules, a negative times a negative is a positive. So a negative divided by a negative is also a positive. So if we put negative 3 over negative 5, we can also go down 3, left 5 right here. And guess what? It's the same slope. Because if we go from this point that we just plotted, if we go up 3, right 5, we still end up at our same part. So since they're both negative, technically we still end up with a positive slope. Okay? So our line here is going to be dashed. Okay? So there's our dashed line right there. Okay? Because it's strictly less than. Okay, now we want to pick a point. Again, an easy point that we can test is 0, 0. 0, 0 is not on this line. So let's plug 0 into our inequality. Okay, negative 3 times 0 plus 5 times 0 is less than 15. We get 0 is less than 15. And of course, we know that that's true. So we can shade the half plane containing that point. Okay, so we want to shade this bottom part here. So the only really difference here that we're looking at with graphing inequalities in standard form is we want to kind of try and put them into slope-intercept form. Okay, so these are slope-intercept form. Right here, it's really only 2 steps. We move our x over, and then we divide by the number in front of the y. Some of you might remember that from that unit we dealt with graphing linear equations. Move the x over, add or subtract the x, divide by the number in front of y. Add or subtract the x, divide by the number in front of y. Okay, that's our 2 steps. So looking at number 2, again, we have 2x minus 6y is greater than or equal to 24. So our first step, add or subtract the x. We're going to subtract 2x here. Okay, get negative 6y is greater than or equal to negative 2x plus 24. Now we're going to divide by the number in front of the y. Divide by negative 6. Now when we divide by negative 6, there's a couple things we have to keep in mind. Okay, negative 2 over negative 6 is going to end up being 1/3. Okay, now 24 divided by negative 6 is going to end up being negative 4. Now I also flipped my inequality from greater than or equal to less than or equal to. And hopefully you guys knew we were going to do that because we're dividing by a negative. Remember, you always flip your inequality if you're dividing or multiplying by a negative number. Okay, so in this case, we're dividing by a negative number, so we flip the inequality. Okay, so We flip this inequality. It's less than or equal to now. And now we pick a point to test. Or let's graph those points first, sorry. So our important points are 0, -4, and 1/3, our y-intercept and our slope. Okay, so let's plot our y-intercept. 0, -4. Our slope is 1/3. We're going to go up 1, right 1, 2, 3. Up 1, right 1, 2, 3. And you guys can keep going. Up 1, right 1, 2, 3, right? Keep going. And our line is going to be solid because it's less than or equal to. Okay? Remember, less than or equal to or greater than or equal to, solid line. Okay, so let's pick a point to test. Again, easy point to test. 0, 0 right there. Okay? So let's plug zeros in for x and y. We're going to end up with 2 times 0 minus 6 times 0 is greater than or equal to 24. 2 times 0 minus 6 times 0 is greater than or equal to 24. Okay? So, of course, simplifying this, we would get 0 is greater than or equal to 24. Is that a true statement? Is 0 greater than or equal to 24? Hopefully we're all saying no. Okay? So this is not true. So we have to shade the half of the plane that does not contain 0, 0. So since this was made the inequality false, we have to shade the other half, which is actually this bottom half here. Okay? So that would be our second example. So this was actually a really good example, okay? We moved it over to slope-intercept form, and while we were moving it, we had to remember our rule of flipping the inequality here. Okay, so that was a good refresher. And then we still graphed these and plugged them in, but this is our first example we've had that's been false, and we've had to shade the other half of the plane. Okay, so if it's false, you want to shade the half of the plane that does not contain the point that you picked. Okay, so let's look at number 3. We have 7x plus 8y is greater than negative 56. Okay, so again, we want to add or subtract our x. We're going to subtract 7x in this case. Okay, so we'd get 8y is greater than negative 7x minus 56. Okay, 8y is greater than negative 7x minus 56. Okay, now my last step here to get it in slope-intercept is to divide by the number in front of y. My number in front of y is 8. So we're going to divide both sides by 8. I'm going to get y is greater than negative 7/8 x minus 7. Y is greater than negative 7/8 x minus 7. Okay, so again, we have our slope now, negative 7/8, and our y-intercept, negative 7. Let's write them out. 0, comma, negative 7 is my y-intercept, and my slope is negative 7/8. So let's plot my point, 0, negative 7. Should be all the way down here. Now, negative 7/8, I can't go down 7, right 8. Okay? So instead, I can go up 7, left 8, which would be all the way over here, I believe. Okay? So if you can't go down 7, right 8, then we can go up 7, left 8. Okay? Now, this is strictly greater than, so it's going to have a dashed boundary line. Okay? Now, again, another easy point to test. 0, 0. So let's plug it in. Okay, we have 7 times 0 plus 8 times 0 is greater than negative 56. Of course, we know 7 times 0 plus 8 times 0 is just 0. Okay, so we have 0 is greater than negative 56. 0 is greater than negative 56. And of course, let's see if that's true. Is 0 greater than negative 56? Absolutely it is, right? So let's shade that half of the plane. So there we are, shading that half right there. Okay, so that's our last example. Okay, so hopefully we're doing okay with this stuff, guys. This stuff shouldn't be too new for us. We know standard form. We know how to get it in slope-intercept. We know how to graph, okay? Let me know if you guys have any questions.